Hello everyone and welcome back to Just Finish Coding. My name is Sriram and this video is the fifth part of the car chase series. In case you haven't watched parts 1 to 4, there will be a card for you right here. By the end of this video, you will have the motion of the player car along with its collisions with the borders. We can start by correcting a mistake that was made in part 4. We head over to the border sprite. Within the main repeat until loop, we set the x position to be x position divided by 3 multiplied by 1. This is a mistake because the x position of the border should depend on the x position of the car and not of itself. Thus, we change it this way. Now we can get back into the car sprite and rig up the movement. When the green flag is clicked, we send the car to the center of the stage. There will be a separate position for the main game and a separate position for the lobby. In the lobby, the car will stay at the center of the stage, while in the main game, the car will move about at the bottom of the stage. Within a forever loop, we have an if-then-else to distinguish if the game setting is playing or if the game setting is lobby. Before we program the main game code, however, we can finish off all the code for the car movement within the game lobby. Here, we create a new variable for this sprite only called xvel. The name should be self-explanatory. The variable stores the velocity of the car in the x direction. While we are in the game lobby, the car will basically be stationary after the animation, so we set that to 0. We want the car to move animatedly to the center of the stage. We have two blocks for this. We change y by 0 minus y position, the whole divided by 5, and we change x by 0 minus x position, the whole divided by 5. We will be twisting and turning the car during the game, so we make sure to point in 0 degrees, which means point upwards. Okay, if you test out the program now, the car animation should work fine. However, the car's shadow should be in the wrong position. This is simply because we haven't programmed the shadow sprite to follow the car. We will do this in the next video, so at the moment you can go to the sprite and hide it. If the game setting is playing, we'd want the car to move downwards animatedly to a y position of -100. We can use the same trick that we used for the other sprites. We change y by -100 minus y position, the whole divided by 5. After this, we create a new block called tick. All the car action and motion during the game will happen within this block. After throwing the block into the forever loop, we can start with some basic keyboard sensing. The program will be controlled by both the arrows and the WASD keys. If the right arrow key is pressed or the D key is pressed, then we change xvel by 1. If the left arrow key is pressed or the A key is pressed, then we change xvel by -1. If we leave xvel this way and set up the x position of the car as a function of this variable, then the car will keep on moving and never stop. In the real world, the car naturally decelerates because of the friction. In order to simulate this, we set xvel to a ninth of itself. Eventually, xvel will get so small that Scratch will just round it off to 0. Next, we change x by xvel. We also point in the direction xvel multiplied by 1.5. You could play around with the 1.5 values and see what you think works best. You just have to increase it if you want the car to tilt more when you press the arrow keys. To make things more organized, we create another function called check border collisions. All the code that will be necessary for deciding whether the car is colliding with the border and what direction the reaction will act in will be done within this block. It's quite helpful to think of Newton's third law here. For every action, there's an equal and opposite reaction. If the car hits the border on its left, it will be pushed to the right. And if the car hits the border on its right, it will be pushed to the left. Having conditions to test these is quite simple. First, we check if xvel is greater than 0 and if the border is being touched. If this is true, then it means that the car hit the border by moving to the right. In case this happens, we will have to be thrown off to the left. Of course, in the second case, we will be checking for a collision from the left side, so we check here if x velocity is less than 0. If it is, then the car should be pushed to the right. We will be reusing the code that we're about to put in multiple times, so it's much more efficient to create a function for each of them. We can call the first one car physics left. It is extremely important to click the checkbox which says run without screen refresh. Without this, the whole motion starts to break down. For the second if statement, we create a new block called car physics right. Once again, we run it without screen refresh. At this point, we have to define each of the functions. If the car should move to the right, then the border is being touched on the left. We first move the car towards the right until it is no longer touching the border. This is only the first step. For the reaction force, we boost the x velocity to the right so that the main game tick code can apply to it. Let's give those instructions to the sprite in code. For car physics right, we have a repeat until not touching borders. Within this, we change x by 1. This will make sure that the car is no longer touching the border. Once this is done, we set xval to 10 so that it appears as if the car has been thrown off to the right. Great, we can now do a similar thing for car physics left. We just replace x by -1 and set the x velocity variable to -10 instead of +10. This is the same logic except that the car will be pushed to the left. Once we get back into the check border collisions function, we can put in car physics left if the x velocity is greater than 0 and put in car physics right if the x velocity is less than 0. In addition to these two cases, there is a third case which is possible though unlikely. The x velocity can be 0 and the car may still hit the border due to the fact that the border is not a perfectly straight line. So within the third if then statement, we check if the car is touching the border and the x velocity is 0. In this case, we don't really know which side the border is touching the car. It may be on the left or it may be on the right. To find this out, we create a new block called test border side. Once again, it is very important to check the run without screen refresh checkbox. We will program this function in such a way that the side the collision is happening on will be stored in a variable. We can create that variable right away. We call it side collision and set it for this sprite only. Within the if then statement, we throw in the test border side function and then get into the if then else statement. As I just mentioned, within the test border side function, we will make sure that the side collision variable assumes the correct value. So we check if side collision is left. If it is, then Newton's third law dictates that we move to the right. Therefore, we put in the car physics right block. If the side collision is right, then we do the opposite and put in the car physics left block. Alright, the last thing we have to do is set up the test border side block. First, we will check if the border is on the left and then we will check if the border is on the right. We change x position by -10 and then check if the border is being touched. If it is, then we set side collision to left. We need to get back to the original position, so we change x by 10 again. For the second part, we have to test collision to the right. We change x position by 10 and check if the border is being touched. If it is, then we set side collision to right. We move back to the left by changing x by -10. Great, that's going to be everything that has to be done for this video. If you test out the program now, the car should run smoothly in the play screen. The collisions with the border on both sides should lead to a hit. All that's left now is the obstacle collision and the health bar. If you've enjoyed this video, please make sure you leave a like and also don't forget to subscribe and turn on the notification bell. Thank you so much for watching and I'll see you in the next video.